Today, we'll be solving LeetCode 142, Linked List Cycle 2. This is a medium-level linked list problem that is very popular in interviews. The task is to detect if a linked list contains a cycle, and if it does, we need to return the node where that cycle begins. If no cycle exists, we return null. A cycle in a linked list happens when some node points back to a previous node, creating an infinite loop. The challenge is not just detecting the cycle, but also identifying the exact node where the cycle starts. Now, let's think about how to solve this. A naive approach would be to use a hash set and store every node we visit. If we ever see the same node twice, that's the start of the cycle. But that takes extra space, and the question encourages us to solve it in constant space. That's where Floyd's cycle detection algorithm, also called the Tortoise and Hare algorithm, comes in. This algorithm uses two pointers moving at different speeds to detect a cycle. If a cycle exists, the fast pointer and the slow pointer will eventually meet. Then, to find the starting node of the cycle, we use a neat trick: move one pointer back to the head of the list, and keep the other where they met. Then move both forward one step at a time. The node where they meet again is the start of the cycle. Let's walk through the code carefully, line by line, to fully understand why it works. We define our function called detectCycle, which takes head as the input node of the linked list. First, we create two pointers, slow and fast, and set both equal to head. These represent the tortoise and the hare. Next, we enter a while loop that continues as long as fast is not null and fast.next is not null. This ensures we don't accidentally run into an error when moving the fast pointer two steps at a time. Inside this loop, we move slow forward by one step, so we say slow equals slow.next. Then we move fast forward by two steps, so we say fast equals fast.next.next. After updating the pointers, we check if slow is equal to fast. If they meet, that means a cycle exists. When this happens, we break out of the loop. If the while loop ends without slow and fast ever meeting, that means there is no cycle, so we simply return null. Now, if we did find a cycle, we need to locate the starting node of that cycle. To do this, we reset one pointer back to head. Let's move slow back to head, and keep fast where it is. Then, we enter another while loop. This time, we move both slow and fast one step at a time. So slow equals slow.next, and fast equals fast.next. Eventually, they will meet again, and the node where they meet is the start of the cycle. At that point, we return slow, which is the node where the cycle begins. This works because of a mathematical property of linked lists with cycles. The distance from the head to the start of the cycle is the same as the distance from the meeting point back to the start of the cycle. That's why resetting one pointer to the head and moving both step by step works perfectly. The time complexity of this algorithm is O of n, because in the worst case we may traverse the entire list, but each pointer only moves forward and does not revisit nodes infinitely. The space complexity is O of 1, since we are only using two pointers and no extra data structures. And that's how you solve LeetCode 142, Linked List Cycle 2. Thank you for watching, and let's keep learning.